This is the M4 Sherman medium tank. It's had a lot of bad press, both during and after the Second World War, and what we're going to do today is look at some of those things that people have said were poor about it. It's a relatively low velocity gun. It had a reputation for bursting into flames when it was hit and penetrated, and generally speaking, it was seen as inferior to German heavy tanks that it sometimes came up against. But what we're going to do is we're going to look at it more in the round. We're going to look at its design parameters, how and why it was produced, what it was produced to do. And I think when we look at that and then compare some of the things that it could do that German equivalents couldn't do, I think we'll come up with a more nuanced view and we'll get a better appreciation of just how effective the Sherman was as a weapon of war in the Second World War. So what was the Sherman for? I think this is the first common misconception, in that when it was designed, it wasn't designed to be a tank to fight other tanks. In the 1930s, the Americans were looking at developing a tank which they called the M4A4. Initial versions were equipped with a massive number of machine guns, 9 machine guns in all, which again points to that tanks were not for fighting other tanks. So you had two very distinct sorts of armoured vehicle. You had a tank to take on enemy infantry and anti-tank guns, so it was an infantry support vehicle, and a tank destroyer, which had a higher velocity gun, was more manoeuvrable and was there to take on the enemy tank forces. But of course, this sort of rather fell apart as soon as war began.
Precisely at dawn on September 1st, without warning, the German Wehrmacht rolled over the Polish border.
Of course, when you're on a battlefield, you're never just going to meet enemy infantry, or you're never just going to meet enemy tank forces. Especially the Germans, they operate in these mixed Kampfgruppe. There's an immediate realisation when the Americans are looking at the opening stages of the war that they need to be able to take on enemy dug-in infantry, get them out of entrenchments, etc. So a main gun was going to be needed on any future medium tank. So as a stopgap, while the war's still going on, the M3 medium tank is developed, which it becomes known as the Lee Grant. But the problems with that were the tank was very high, even higher than the Sherman, which had a reputation for being quite a high battle tank. And also, because the 75mm gun was in the hull front, it had a very limited angle of traverse. For all those reasons, it was realised that another tank was going to be needed. So another team of designers were looking at ways to use the chassis and the running gear of the M3 and how to place a much bigger turret on top which could take that 75mm gun. And that is how we get to this, the M4 Sherman, which rolls off the production line for the first time in February 1942, while the M2A1 is still being manufactured. So again, that points to the fact that this doctrinal hang-up was still there, and in fact it was still there until 1944.
Japanese planes had been sowing death and destruction for an hour on American outposts in the Pacific.
By now America is at war with Japan and Germany, and there's a need for thousands of these new tanks. Roosevelt wanted 45,000 tanks per annum, which led to a series of decisions that the ease of production, simplicity of production, rate of production would all trump things like battlefield survivability and firepower. If the tank was made simple enough and upgradable enough, those problems when they were encountered could be overcome. What was needed was a mass of tanks, tanks that were reliable, tanks that would stay in combat, tanks that could be upgraded. Initially, the first type of Sherman was the M4A1, which had a cast hull and the R975 radial engine, and it was almost immediately realised when they were producing these that the engine was too complicated and the casting of a hull in one piece was also a very difficult manufacturing process. So a variety of variants and sub-variants were going to be needed, 5 main variants, and there were sub-variants of those across 10 main manufacturing plants across the United States. But wherever possible, the same mechanical pieces of equipment and electronic equipment were used to manufacture all the different sub-variants of the Shermans across all of the range of manufacturing plants. So, for example, things like the M10 and M36 tank destroyers and other vehicle types, self-propelled artillery types, all use basically the same chassis, engine, differential, as did the M4 Sherman, and this enabled tens of thousands of these vehicles to be manufactured and kept in the field relatively successfully. This is in complete contrast to the German approach, which is almost to over-engineer everything. It's too difficult to maintain in the field. And because of the interference of Adolf Hitler in incessantly wanting his tanks to be heavier and bigger and larger, he was obsessed with that sort of thing, in the field these things were constantly breaking down. So with the Sherman, for example, the front section of the tank here, which was the same across all the variants, which contains the gearbox, the differential, the final drives, and it's a single one-piece unit that basically you unbolt, take off, and put another one on. You're not worried about taking little individual bits of parts off. It's just a sub-unit assembly, reassembly, and then the tank's fixed and away it goes.
From Berlin, a voice cried out the Allies must be hurled into the sea before another day had burned its hole in history. Locked in battle, the armies clashed.
What about the Sherman's battlefield effectiveness? There are three main considerations in every type of tank design, and that is survivability on the battlefield, its firepower, and its manoeuvrability. And I'll add a fourth one onto that, which I think is an incredible one, which is the reliability factor, which underpins all of the above. So the Shermans had this bad rap over during the war and in the interwar period, mainly because people insist on comparing between the Sherman tank and the heavier German tanks. It's rather like comparing a Ford Escort, a mass-produced family car, with a Ferrari. If you're comparing straight line speed, the Ferrari is going to win every time. But if you're going to compare things like how cheap it is to manufacture, how quickly you can manufacture them, the Ford Escort's going to win every time. So I think the best vehicle to compare the Sherman with would be something like the Panzer IV. Both start off as pre-war infantry support tanks, and then as the war goes on, they're modified, upgraded, changed, and they both have roughly the same battlefield capabilities. You are comparing eggs with eggs. So, armour. This tank is a welded version, and there are cast-all Sherman versions as well. They all carry roughly the same amount of armour for the different variants, and it's moderately successful in that it won't keep out a high-velocity 75mm or 88mm Tiger round, but then again it's not supposed to. It's an infantry support tank. It's there to take on moderate-sized anti-tank guns like the 50mm pack, and also to be survivable in an infantry battle where it's going to get lots of artillery shells landing on and around it. It's perfectly survivable in that sense. The other problem is it's got this reputation for almost instantly bursting into flames every time it was penetrated. It was estimated from analysis that it would burst into flames between 60% and 80% of the time when it was penetrated. It's not a slow burn, it's sort of woof, the tank goes up. So for these reasons, the Allied tank crews began to get very worried about what might happen to them in the interior of a tank. On further analysis, it was understood it was where the ammunition was stowed. So initially, they welded extra plates on the side of the tank, and you can see them on the side of this tank here, to give an extra depth of armour in front of where the ammunition is stored, which doesn't really work. But then what in the end they come up with is something called wet stowage. They're armoured boxes which are set into the floor of the tank, and there's one in the turret as well. The void in between each is filled with a mixture of water, antifreeze basically for cold weather conditions, and a rust inhibitor. The fluid that's in the outer wall floods in and then stops the fire from starting in the first place. And this was tremendously successful. It cut down the rate of flammability from 60 to 80% when hit down to about 10 to 15%. So a very effective upgrade fitted into the Sherman tanks. So, your gun. This Sherman is equipped with an M3 75mm medium velocity gun. It has a really good high explosive round, it's really effective at taking on enemy infantry, which was what it's designed for. It's moderate in terms of its armour penetration, so it can effectively take on and defeat the armour of the Panzer IV and the Stug 3, which are the main two medium tank destroyer equivalents it's going to come up against. It can't penetrate the frontal armour of the heavier Panther and Tiger tanks, but that's not what it's supposed to be there for. Oh, there you are. I just managed to say tank there and then the light went out. As the war developed, tanks on both sides were upgraded and made heavier and thicker armour. It was realised that the Sherman itself needed to be upgunned, so a 76mm gun was developed, only 1mm difference, but quite a lot in terms of the velocity of the projectile. And the idea was you'd use a mix of 76mm guns and 75mm guns in the same unit, because you didn't want to lose the ability to fire the really good high explosive round of the 75mm. The problem with the 76 was that it was a bit better than the 75, but it still wasn't anywhere near as good as the German equivalent 75 on the Panther or the 88 on the Tiger. The British take a very different approach. They decide they need a very high velocity weapon to match that of the Panther and the Tiger. So they come up with the idea of putting a 17-pounder anti-tank gun into the Sherman, and it becomes what's known as the Sherman Firefly. And to do that, they need to modify the turret by cutting the back of the turret out and putting a box on the back. And the other thing they have to do is they have to turn the 17-pounder breech through 90 degrees. So the poor loader, when he's trying to load the gun, is loading it at a funny angle, which lowers the rate of fire and makes it ergonomically not very good. But the British decided the payoff was worth it. So that's your gun. So finally, manoeuvrability. We've talked about these 5 different versions of engine which the Sherman has, and to be honest, they give out roughly the same sort of top speed, which is in the mid-20s miles an hour, which compares very favourably with the Mark IV. Again, we're talking about the M4 Sherman and its ability to be upgraded. The thing that comes to notice is that because the Sherman has a narrower track, it's got quite a high ground pressure, i.e. the weight going through the tank into the ground along the track is high, and so eventually the plan is developed to change, replace, upgrade the suspension system, which is horizontal volute spring suspension. Basically the springs in the suspension are that way rather than that way, which allows a much wider track to be fitted, which means it's got a much more even, much lower ground pressure, much more manoeuvrable, especially across boggy ground. I think it's fair to say that these make the Sherman a capable rather than a super tank on the battlefield. But I think it's important to remember that there are several things that the Sherman could do that no Germany tank equivalent could do, which could and did give it a significant battlefield advantage from time to time. The 3 main things that the Sherman could do that gave it this advantage was its rate of turret traverse, the rate of fire, the amount of weight of fire it could put down in a given period of time, and the gyro stabilisation. So the Sherman was gyro stabilised in the vertical plane, which means it didn't do that as it went along. Now, this system was very complicated. It was so complicated that many American tank crews actually switched it off. But because you know the actual attitude of your gun, whereas the German tank commander hasn't got a clue because his tank's been doing this, you are likely to be able to get off the first round because you can lay your gun quicker than he can. The second advantage is the very high rate of fire of the Sherman. It can fire between 15 and 20 rounds a minute. Now, if you compare that to the Tiger, which can do about 4 to 6, Panther that can do just a little bit more, you're firing at sort of almost between 3 and 4 times the rate of your enemy. Which means that if you're in a position where you've got a significant number of Shermans, which is almost inevitably the case, because don't forget, you've mass-produced them, so you're outproducing the Germans. The Germans could easily be receiving 8 to 10 rounds coming in for every round he's firing out. Now, you might say, well, what advantages does that give you if the rounds that are hitting the front of your tank aren't going to penetrate? Well, if you've got successive hits hitting your armour, it doesn't really matter, because the first thing you're going to have to do is your commander is going to have to duck down inside the turret, which decreases the combat effectiveness of the tank. It only needs one of those shells to hit a track, a periscope, the hatch cover, which is a way that several Tigers get knocked out. All those things will effectively disable the tank and will, in most cases, cause the crew to bail out. Finally, there's the turret traverse. So a Sherman can rotate its turret in 17 seconds at full speed. A Panzer IV is 26 seconds, and a Tiger and a Panther take nearly a minute. So that's a very significant difference, which means you're much more likely to be able to manoeuvre your turret to get in the first shot, or first several shots, before that Tiger or before that Panther can traverse its turret to get shot back at you. So now on to our particular tank at the IWM. This is an M4A4, which is the American way of saying it, Sherman 5 if you're British. Unlike, say, aircraft, which have very detailed service histories and you know which squadrons they've been to, that's not the same with tanks and armoured vehicles. They're basically almost seen as throwaway items where you know, it breaks, you throw it away, you get another one, which sort of fits again with this overall Allied idea of, you know, mass production, simplicity, upgradability, that sort of thing. So we didn't know what it was or who had used it until we started to very slowly strip back the layers of paint for its restoration, and on the very bottom we found the markings that it's been repainted in now, which is I think A Squadron 2nd Battalion Grenadier Guards Armoured Division. So they fought in Operation Goodwood in Normandy, Bluecoat in Normandy, Market Garden, Veritable in the Reichswald, and then on into Germany. So a succession of military operations where they took very significant casualties over the course of the war. We don't know which of those it took part in, we just know it took part in at least one of them. So to sum up, the Sherman was a moderate tank in all respects, firepower, survivability, manoeuvrability, but it was much better in terms of reliability, ease of production and ease of maintenance in the field. It fares well when compared to the German Panzer IV, which is the German equivalent. It's only when you compare it to the higher specification, much bigger, much heavier German heavy tanks, which it wasn't supposed to be coming up against and fighting as a matter of course anyway, does it fare badly. That was obviously hard on the Allied tank crews in the Second World War who felt shortchanged, but the fact that these things could be made in their thousands and could effectively swamp the enemy opposition with numbers, that is an advantage all of its own. And this is the crux of the matter. The Allies had decided that producing large numbers of vehicles that were reliable and upgradable was more important than sheer battlefield survivability in a one-on-one combat situation. And they were right. A good example of this is the French army in the post-war period. They inherited a Panther tank force of captured German Panther tanks and Sherman Lend-Lease tanks from the Americans. And the Sherman stayed in service with the post-war French army much longer than the Panthers. Simple reason, the Panthers weren't reliable, they kept breaking down, the Shermans could be depended upon. The Shermans stayed in service well into the 1950s. They fought on both sides in the Indo-Pakistan wars, and the last frontline combat unit of Sherman tanks went out of service in 2003 with the Chilean army.